question 7 is now our trigonometric identities and solving trig equations. So as soon as I see one of these, or even at the start of the paper, I would write down what I know for core 2, and that is sine squared x plus cos squared x equals 1, and sine x over cos x equals tan x. Then let's have a look at the question, have a look at where we're trying to get to. Now we're trying to get to tan squared x. It's worth noting at this point that if sine x over cos x is tan x, then if I square both sides, that must also be true. So sine squared x over cos squared x is tan squared x. Remembering this tan squared is just a shorthand way of writing tan x all squared, the same as sine squared and cos squared. Right, so let's just start playing with these. Sometimes with trig equations you don't exactly know where you're going. The way to do this is to just practice lots of them so you can pick up on the sort of techniques you might need. Well, on the bottom equation I've got a 1 minus sine squared x. If I take this identity and rearrange it, I get cos squared x equals 1 minus sine squared x, which matches the bottom of the fraction. So let's replace that. So I've got cos squared x plus 4 sine squared x equals 7 over cos squared x. Well, has that helped me? Well, yes, because now I can split this fraction up. Now I haven't got a plus or a minus in the denominator. I can write that as cos squared x over cos squared x plus 4 sine squared x over cos squared x equals 7. You might think of that as a backward step, as we're taking a single fraction and writing it in 2 instead of taking 2 and writing it in 1. But what happens now is we've got something lovely in that we've got cos squared x over cos squared x, which is 1. And then I've got sine squared x over cos squared x, which we know is tan squared x, and that equals 7. And I'm almost there. 4 tan squared x is 6. Tan squared x is 6 over 4. And if you simplify 6 over 4, you get b over 2, which was what was required.